I'm sure most of you have probably seen something like this. Let's look into the physics behind this. First up is angular momentum. Angular momentum can be defined as mass times velocity times the radius. M is the mass of the object, which in our case is the water bottle. V is the velocity, or the amount of spin you give the water bottle. Next, R, or the radius, or how big you make the circle when you spin the water bottle. As shown here, you can have a small circle, which you would have to have a larger velocity to make the water bottles land, or if you were to make a big circle with the water bottle, you wouldn't have to give as much spin. Next up, force, which is what slows down the water bottle so that it can land upright. In this case, the force is the center of gravity of the water bottle. Change in angular momentum, or L, is given by the amount of force applied multiplied by the amount of time the force is applied. Now we're going to look at what happens if we were to have a constant angular momentum. And as I said earlier, when the radius goes down, the amount of velocity that you have to give goes up, and then the opposite, so that when the radius goes up, the velocity goes down. It makes sense mathematically, because if L is not changing and M doesn't change, then V and R are going to be jointly related as they change. Now let's look at liquid dynamics and why it is that you need 1/3 full bottle of water. Look at the water here as it moves in a weird formation. Here's what happened when I tried to flip a full bottle, or even drop one. Here's what happened when there wasn't enough water. And here's what happened when I used erasers. And that is the science behind the water bottle flip. Thanks for watching.